In this video, we are going to do some extra practice on other forms of direct proportion. So once again, from what we've already covered, is if I have two variables, x and y, and I want to prove that they are in direct proportion, I use the condition that y over x or x over y for any corresponding values is going to be equal to a constant. So if I can also establish that my y equals to a constant times x, then they are in direct proportionality. Now we could have other forms. When you look at what we have here, they are kind of like single letter expressions, but I could have other expressions which are in direct proportionality. For example, if the relationship between two variables is in the form of y equals to x squared plus 3, I can write that if I divide by x squared plus 3 on both sides, I'm going to get y out of x squared plus 3 equals to 1. Now 1 is a constant. This means that y is directly proportional to x squared plus 3. Unlike here, we had only single letters like x and y, but here we have expressions y and x squared plus 3. In this case, y is not proportional to x, is not directly proportional to x, but it is directly proportional to x squared plus 3. What is the skill and aim here? You make sure that you divide variables so that on one end they are equal to 1. Let me illustrate with the homework from yesterday. We have questions that t equals to square root of x, and they've asked us to, for each of the following equations, state which two terms are in direct proportion and show your reasons. Okay, so because I have, let me start with part A. I do have that t equals to square root of s. So I'm going to divide by square root of s, so that on one side I have the condition, this condition that if I divide any two variables, I should have a constant. So that's why I'm dividing by root s on both sides. Now this would mean, so this is a 1. This would mean that t divided by square root of s equals to a 1, which is a constant. So meaning that t is directly proportional to square root of s. Please note, it's not directly proportional to s, but it's directly proportional to the square root of s. My part B was y squared equals to 7n. So I have y squared equals to 7n. So I'll divide by n. I'll divide by n. So I'll have y squared divided by n equals to 7. 7 is a constant, it's a number. So meaning that y squared is directly proportional to n. So once again, what's the aim? To establish, to go to the condition that my variable, this time let me use variable a over variable b is a constant. if I can establish that, then the two variables a and b are in direct proportionality. Let me try out part C and part D also. Part C is r equals to 5 into w plus 1 squared. So I have r equals to 5w plus 1 squared. I'll divide by w plus 1 squared because it has the variable plus 1 squared. So those cancel out so that I have r divided by w plus 1 squared equals to 5. Now 5 is a constant because it's a number, meaning that r is directly proportional to w plus 1 squared. Whatever is on this side, whatever you've divided by, they are in direct proportionality. And lastly, I have y equals to 2 out of x. So that's part D. Y equals to 2 out of x. So I'm going to divide by 1 over x, because this, I could write this equation as y equals to 1 over x times 2. So divide by 1 over x, divide by 1 over x. So this would mean that y divided by 1 over x equals to 2, because those cancel out, and 2 is a constant. This would mean that y is directly proportional to 1 over x. So that's how we do it. You're going to have some extra numbers to practice.